To begin this tutorial, the first thing we will do is go to the Shanks tab. For this model, we will use the Signet command. Without selecting any preset, we will click on Edit to start customizing our model. We will change the top profile by clicking on the image. Inside the Asset Selector window, we will select Asset 002. Then we will click Accept. Now we will simply change the parameters. We will set the width to 12 millimeters, then change the height to 9.84 millimeters. You can switch the display mode to shaded to better appreciate the changes. We will adjust the height position to 2.70 millimeters. We will leave the bottom profile as it is, but we will change the height of the bottom profile to 1.80 millimeters. Finally, we will change the width middle profile to 2.52 millimeters. After that, we will press Accept to create our base shank. To continue, we will create a series of curves to keep building our model. The first thing we will do is select one of the user layers to create the reference curves on it. Go to the Curve tab and use the Extract IsoCurve command. Enlarge the perspective view to make the task easier. Select the shank as the surface. If you see that the line is horizontal, in the command bar you can change the direction to V. Now make sure you have the OSNAP option activated to get help from the guides. Select a point where the guides show end or mid to ensure that the curve is created in the center. We will do the same on the other side. Now we will extract two more isocurves, also using the reference guides to create the curves in the center on both sides of the shank. To continue, we will use the Blend Curve command to join the pairs of curves. To do this, select the command, then select the top part of one of the curves, and then the other from the opposite side. To make the process easier, we will use the front view, and we will make sure that the tangency options are activated. Then, by pressing Shift, if we click on one of the curve editing points, we can move both at the same time. We will use that point to position the curve approximately 5 millimeters above the top of the shank. Then press OK to accept. We now have the first curve, so let's move on to the next one. We will use the Blend command again, then select the other two curves. Now, it is very important to bring the highest point of one curve as close as possible to the highest point of the other curve. Check all the necessary views and take your time. The closer the curves are, the better. As you can see, this will be my result. Then you can center all views using Pan, Zoom, and Rotate, and then Zoom Extents All. Since we are going to create a network surface, we also need the base curves. To do this, we will use the Duplicate Edge command. Select the edges of the upper base of the shank and press Enter to create that curve. Now select it, and in the top left corner use the Split command to cut the curve. As the cutting element, we will use the curve that joins the widest parts of the shank. Press Enter to cut. As you can see, we now have two curves. To build the new surface, select all the curves on the top part. Go to the Surface tab, then use the Network Surface command to create the surface. We will leave the measurements at 0.01 and the position as default. Press OK. Select the surface and change it to the metal layer. If it is inverted, simply type Flip in the command bar to orient it correctly. We will move this surface to another layer so we can hide it. Go back to the Curve tab and use the Offset command. Select the first curve and type 0.8 to create the offset. Then press Enter. To repeat the command, right-click, then create the offset for the rest of the curves. All of them will be offset 0.8 millimeters toward the inside. Take your time. When you have all the curves, we need to make sure that the bottom points touch each other so we can create the surface. With OSNAP activated, you can select the curve and then the bottom point. If it's easier, hide the rest of the elements to better see the curves. But before positioning the points, we will reduce the number of points in the two curves. To do this, select the curves and use the Fit command. In the command bar, type 0.1 and then press Enter to confirm. As you can see, when selecting a point and moving it with the Move command, it's not very easy to find the point we need. Try switching to the top view. It will be easier. When you see the end guide, that is the correct position. Do the same with the rest of the points. For the curves in the other direction, you will see the mid-guides to position them correctly. When finished, check that all the points are in their correct position. When everything is positioned, simply select the inner curves, then go to the Surface tab, and use the Network Surface command again. As I mentioned before, if you see that it appears incorrectly oriented, simply type Flip in the command bar and press Enter. Now we have two surfaces with a space between them of 0.8 millimeters. This will help us hollow out our ring. We will show the shank, then select it and go to the Transform tab. We will use the Copy command, and in the command bar click the In Place option to create a copy in the same position. We will move one of the shanks to another layer and hide it, then select the one that remains and edit it. The purpose of this shank is to modify it so that it is 0.8 millimeters smaller on all sides. This way we can use it to hollow out the shank of the ring and reduce its weight. The first thing we will do is check the diameter of our shank. In this case, it is 16.92 millimeters. To modify this diameter, we will select a custom measurement. Since we need to subtract 0.8 millimeters from each side, we must reduce it by 1.6 millimeters in total. So if we subtract this from the diameter, we get 15.32. We will then select the measurement closest to this, in this case 15.30. We will do the same with all the shank parameters. We will adjust the width to 10.40 millimeters, the height to 8.24 millimeters. Then we will set the width bottom profile to 0.15 millimeters, the height bottom profile to 1 millimeter. Finally, we will change the width middle profile to 0.92 millimeters and the height middle profile to 0.90 millimeters. Now you can show the other shank to see how much material we will hollow out, although we still need to position the inner shank. Accept the command. From the front view, select the inner shank, and inside the Align button select Align Top. Position the inner shank at the same height as the outer shank. We will show all views again. As you can see, we will only hollow out part of the shank, avoiding the bottom part. This way we achieve a smooth hollowing. Now let's join the pieces. First, the inner part. Select the top part and type Hide to hide it temporarily. Then go to the Solid tab and use the Extract Surface command. In the command bar, keep the Copy option set to No. Select the surface and press Enter to extract it, then delete it. Now type Show to display the part we hid. Now select the two parts and join them by clicking Join. As you can see in the command bar, it says Unable to join. To fix this, use the Join Edge command. Select the edge of the surface and then select the other edge. Now select the model and go to the Analyze tab. Use the Show Edges command. This way we can see the edges of the model and know which ones are still unjoined. Then go back to the Solid tab and join the missing edges. Once finished, to check that we have obtained a solid, simply select the ring and press F3 to open its properties. You can see that under Type it says Closed Solid Poly Surface. We will follow the same process with the other surfaces. First, we will extract the surface of the shank and delete it. Then we will show the rest and join them as we did before. Remember to analyze the model to see which edges are still missing. Join them and check the properties. Now we almost have it. Show both rings. In the Solid tab, use the Boolean difference command. Select the outer ring, press Enter. Then select the inner ring and press Enter. We now have our hollowed-out ring. The only thing left is to create our pave to complete the model. To do this, the first thing we will do is extract the top surface. Make sure that in the command bar the copy option is set to Yes. Also, show the curves. We will only need the one crossing the surface. The rest can be hidden. Select the surface you just extracted, then go to the Diamonds tab. Use the Pavé Along Surface command. Add the surface to the selector. Then click Add with the default measurements. In the command bar, change the direction option to V. Use the curve as reference and select the midpoint of the top part. Now click Accept to create the gems. We will use them as a reference for the automatic pave. Now use the automatic Pavé command. Then add the surface to the command panel. Also add the gems to the selector. When we finish positioning the gems, we will add the cutters. You can activate them in this tab. We will leave them for later. In the Gems tab, you can activate gem visualization. Then select all of them and lock them. They will serve as a reference for generating the pavé. We will add several more sizes: 1.2, 1.1, 1.0. We will also add one of 1.5 and 0.9. We will activate horizontal symmetry and then click Generate. When the command finishes computing, we will review the generated pavé. In my case, I see one gem that is too small. I will select it and increase its size so that it matches better with the others. You can recompute so it recalculates the spacing. Remember, you can resize, move, or even add or delete gems. Take your time to adjust the pavé until the result matches your taste. Once you have it, go to the Prongs tab. For this model, we will use a diameter of 0.6 millimeters. Change the overgirdle to 0.2, undergirdle to 0.5, and finally extension for manufacturing to 0.3 millimeters. Once the parameters are set, simply click Generate. In the areas where there is conflict between the gems due to measurements, the command will leave the positioning of the prongs up to us. We can manually add the prongs we need. Select different sizes, add prongs in those areas, and also on the outer areas. The automatic pavé command leaves the positioning of the external prongs to the designer's choice, so you can adjust them according to each client's preferences. Take your time to place all the prongs you need in the way that works best. Once you have all the prongs, go to the Cutters tab. For this model, select the fourth preset and click Show, then simply accept the command. The last thing we need to do is use the cutters. Go to the Solid tab, use the Boolean difference command. Select the shank and press Enter. Then select the cutters and press Enter. Now we have our model fully finished. Hide the parts we don't need. And that's it. The only thing left is to render. I'll leave a sample render as reference, but don't hesitate to create yours and share it with us.